Okay. Once again, welcome to this webinar presented by Aura Solutions. We're going to be doing dispersion modeling for NO2. The webinar is going to be consisting of basically a review of what we now have to deal with in terms of the new 1-hour NO2 National Ambient Air Quality Standard. I will talk about EPA's three-tiered approach for modeling NO2. Talk a little bit about EPA's ambient ratio method, the ARM, and then what's called Tier 3, the ozone limiting method, and plume volume molar ratio method. Then a little discussion about some new things that AirMod can do for you as far as being able to process for the 1-hour NO2 max, and then have a little simple, or actually a couple of simple examples. So this is kind of a rehash for all of us, I think, but basically, as you know, the 1-hour NO2 NAQS was promulgated, or actually made effective by US EPA April the 12th of 2010. And the new level of that standard is 100 parts per billion, which converts more or less to about 189 micrograms per cubic meter. The form of the standard, which is the sort of the way we actually determine how we're complying, the how part of it, I guess you might say, is looking at the multi-year average of the 98th percentile of the annual distribution of the daily maximum 1-hour values. And that value cannot exceed 100 parts per billion. EPA, in order to help guide us through sort of the how-tos of this, came out with 3 clarifying memos in 2010 and 2011, and I'll just mention each of them here real quick and sort of what they included. The first one, which came out June 28th of 2010, is the applicability of Appendix W modeling guidance for the 1-hour NO2 NAQS. Appendix W, as you know, is actually EPA's guideline on air quality models. As you know, it is now actually a part of 40 CFR 51, I believe. It's Appendix W to 40 CFR 51. And anyway, what this memo did was it basically affirmed sort of the previous approach that we had as far as using this three-tiered approach, which I'll get to in a minute. And it also discussed some of the technical issues that you might encounter as far as modeling emission inventories, as well as technical issues with applying the three-tiered approach itself. And by the way, these 3 memos are all found. Actually, I think 2 of them are found on the EPA SCRAM website. The last one the first one I just did, and the one after this one are, this one right here, the June 29, 2010, actually is on, I believe it's on the NSR website. But basically, again, June 29, 2010, the memo came out, which was guidance for how to implement the 1-hour NAQS for PSC permitting. And in this memo, EPA introduces us to an interim significant impact level of 4 parts per billion, which is roughly 7.5 micrograms per cubic meter. My understanding is that EPA will formally promulgate a SIL, but until that happens, they have just said, here's one that you can use in the meantime. I believe they've also said that this does not preclude a state from using a SIL that's either more stringent or less stringent than this, as long as it's documented. There's also some discussion in this memo about what to do if you have predicted exceedances of the one error in AQS. And most notably, they note that you can always raise your stack up to its GDP stack height if that gets you out from under any kind of a NO2 exceedance. And then the third memo from March of last year, and again, this one is found in the SCRAM or on the SCRAM website. This is just more clarification regarding how you apply the Appendix W guidance for modeling the one error NO2 max. And in this memo, we now are told that we have a new ambient ratio method, or default ambient ratio method for the 1 hour NO2 max of 0.8. They also say that for the Tier 3, which is the ozone limiting method and plume volume molar ratio method, that there's a default in-stack NO2 NOx ratio of 0.5. The issues of how to handle intermittent sources is discussed. What to evaluate in terms of putting together a background source inventory for cumulative modeling. Discussion of the OLM group all for the ozone limiting method. And then just general guidance on cumulative or full impacts modeling for the 1 hour NO2 standard. Now the three-tiered approach, which I started mentioning at the very beginning of this, and again, if you've been modeling for a while, this is all kind of just a rehash. But basically, the first tier assumes that all the emitted NOx that's coming from your source or sources is NO2, which is, again, very conservative. And if you can show that you meet the NAQS, or if you're below the significant impact level, assuming that all the NOx is NO2, then that's fine. But probably the general rule, that is not going to be the case. At which point you can then go to Tier 2, the ambient ratio method, and basically you just model multiply your Tier 1 results, the total NOx, by some ratio of NO2 to NOx based on ambient monitoring data. And again, this is called the ambient ratio method, or ARM. And then the third tier was what EPA calls a detailed screening method. And they specifically note in their memos the ozone limiting method and the plume volume molar ratio method. And what is important to note here is that these two techniques are not regulatory default options. The Tier 1 and Tier 2 are actually codified in Appendix W as being, here you can do either of these and it's not a problem. But for Tier 3, you do have to get approval by the EPA regional office or the state or whoever is going to be approving your modeling or your modeling protocol on some sort of a case-by-case basis. Now, the Tier 2 ARM, that was originally developed, I think, back in the mid-1990s when we were dealing with annual NO2 impacts. And at that point in time, based on reviews of ambient monitoring data all over the U.S., the decision was made that a good national default ambient ratio method is 0.75. But there's also some language that says that you can develop your own site-specific ARM based on local monitoring data. If you have, one or more NOx monitors that also measure NO2, and what EPA says is that can be applied as a detailed screening method, as well, instead of using the 0.75. And again, the 0.75 is for the annual case only. As I said, it is in the guideline air quality models, and as was noted in one of the three clarifying memos, EPA now says that for 1 hour, the ARM should be 0.8. And then we have our Tier 3 detailed screening methods, OLM and PVMRM. And basically the thought process behind them is that ambient ozone can convert nitric oxide, which is NO, to NO2. So that in essence what you have happening coming out of your stack is you have total NOx. Some of it is already NO2. Probably most of it is NO. And so you're going to have a NO2 ambient concentration would be based upon the NO2 coming out of the stack plus that portion of the NO that's converted by ozone to NO2. Sort of a crude photochemistry type technique. Switching gears here somewhat. With AirMod, we have some new things that have come out. One, well, first of all, as I said earlier, the form of the 1 hour NO2 max is the 98th percentile of the annual distribution of daily 1 hour NO2 maxima. I can't believe how many times I've had to say that and not stumble over it as much as I thought I would. But anyway, prior to AirMod version 11059, we didn't have a tool to tell us what the 98th percentile of the annual distribution of the daily 1 hour NO2 maxima was. And basically what you ended up having to do was run AirMod invoking the post file option, which basically means you want AirMod to save every concentration at every receptor for every hour, which ends up generating huge, huge files. And then once you've saved everything, you could get your designed value via something like our NO2 post processor that would go in and pull that 90th percentile for you automatically. Excuse me. But with AirMod version 11059, which came out at the end of February last year, we do now have a way to automatically pull output from AirMod that you can compare to the form of the 1 hour NO2 standard. And basically, to invoke that, you have to do three things. First of all, the pollutant name that you're using has to be NO2. It can't be NOx or anything other than NO2. Then the other thing, the second thing you have to do is the averaging period in your control options for NO2 must only be for the 1 hour case. In other words, you cannot select 1 hour and annual. And then the third thing, for your output options, the output rank table or level must only be the 8th high. And that's because 8th high corresponds to a 98th percentile. A couple of comments here about SILs or significant impact levels. As I mentioned in the June 29th memo, EPA came out with their interim SIL of 4 parts per billion, roughly 7.5 micrograms per cubic meter. And as you know, because we can't get a permit if we cause or contribute to a violation of the standard, that's where the SIL comes in. So if you ever exceed the SIL, you, by rule or practice or whatever, can't contribute to an exceedance of the standard. And again, when you are looking at a SIL modeling run, since you aren't worried about compliance with the NACT at that point, you're not doing any special processing, so in that case you would select a 1st high rather than an 8th high rank. And unless somebody has more recent information, as far as I've been able to find out, there is no prohibition on being able to use either Tier 2 or Tier 3 while you're doing your SIL modeling. In terms of cumulative impacts, in other words, assuming that you have exceeded the sill, and you do have to grab all the nearby data, or sources rather. And again, more information on the how-tos of that can be found in the EPA memos. But one of the things that they do say is that you can limit your cumulative modeling to only those receptors at which you are significant. That is, you exceed the sill. And in a little bit here, when I start doing the BEAST demonstration, I'm going to show you a new technique that we've incorporated into BEAST that can help you identify and use those receptors much more easily than you could have before. As far as contribution to an exceedance of an ax, in other words, the cause or the contribute part of cause or contribute, that is a little more complex due to how we define a significant impact versus what the form of the NAAQS is. And what the March 1st, 2011 memo said was that basically you have to look at more than just the highest first high from the still when you're doing your cumulative impacts analysis. So at this point, let me go off of PowerPoint here and open up my BEAST file. And if you've taken my AirMod class in the last couple of years, this may look a little familiar. This is our little project site, which is located in northern South Carolina, I believe. The only difference in this one than what you would see in class is that I've actually put in 3 other sources to help us account for the cumulative modeling side of things. So basically, if I am going to model just my source that I'm interested in, which in this case is this one over here called Stack 1. This guy. I look at my control options page. It turns out I've already got my pollutant as NO2, and I am looking at 1 hour, so that's all good and well. Since I'm looking at the still, I can either assume Tier 1 or Tier 2, or I can look at Tier 3. So let's look at what happens if I'm doing Tier 3. For Tier 3 modeling, if you go to the AER options, again this is just for AirMod, and click non-default, when you do, the non-default options box is now active, and you check the NO2 modeling button right here, which then activates this AER NO2 tab. If I go to it, now I can either pick ozone limiting method or PVMRM. There's a spot for the NSAC NO2 to NOx ratio, which we note here the default is 0.5. You can change that, and in fact I'm going to show you here in just a second how you can have multiple NSAC ratios for different stacks. And then the equilibrium ratio here, where the default is 0.9. Again, this value is also in one of the 3 memos. I forget which one, but it is listed in there as being the value you should be using. So the next thing you have is if you only want to use a single hourly background ozone value, you can select use annual ozone value. And again, I apologize. In that, it says annual. It should say same 1 hour value for the whole year, but that's kind of clumsy. So anyway, you can select that. You have a drop down for what units you want to use, and then you put in whatever that background value is. Or if you want to use temporally varying ozone values, you can click this button, and you can select changes by season, month, hour of day, wind speed, season hour, and so forth. And if you did hour, day of week, and basically you have hours 1 through 24, and then you have a value for Monday through Friday, one for Saturday, one for Sunday. Or if you want to be really specific, you can say month, hour, day, week 7. And now you have basically by month, here's Monday, hours 1 through 24, Tuesday, hours 1 through 24, and so forth. So you can do either that one as well. And if you happen to have hourly ozone data that you want to use to drive the chemistry, you can do that as well. And in this case, that is what I have. I have an hourly ozone data file. If you have these in which the fields are delimited by blanks, that works fine. Matter of fact, this is what it would look like. So you have the year 6 for 2006, 1 for January, 1 for January 1st, and then hour 1, and then here's the ozone concentration in parts per million out here. One thing that is very crucial to note is that if you are using an hourly background ozone file, the year for that data has to correspond with the year of your meteorology. Otherwise, ozone doesn't, air mod does not like that, and it will abort on you. So if you have an hourly background ozone value file here, there's a chance that you might have hours that did not have data recorded, missing data, if you will. And so for that case, you would either want to have the annual background ozone value again, which would be the fill-in for missing data. And you can also, or you could do the same thing with the variable background ozone values as well. If you do the hourly background ozone value file and you don't check either of these, it basically means that for that hour, the assumption is all the NOx is NO2. So this is how you would go through setting up with the Tier 3, the detailed screening technique of either OLM or PVMOM. As I mentioned, right here you're telling the system that you want to do everything at 0.5 as far as an in-stack ratio. However, if you go to source options up here, you'll see a tab that says NO2 ratio, and you can create groups in which you can change that NO2 to NOx ratio. So I have a group here called Stack 1, and if I click Select Sources, you'll see that I've highlighted and selected Stack 1 as being, in this case, it's the only stack within the group. And so when AirMod runs, it will override the 0.5 from before with the 0.1 set for Stack 1. Similarly, I have a group called 0.3, and its ratio is set to 0.3, and it turns out that only this source called BKGND1 is the only source in it. So that's the way that you can apply different in-stack NO2 NOx ratios to different sources. In other words, you're not tied to just whatever you set up in the control options AER NO2. So once I do that, I can go to my output options. Oh, and let me look at my meteorology, and let's see, I have a MET file called 2006. My ozone data was 2006, so that should work. And then if I go to my rank options here, since this would be for the significant impact level, I would just click the first high. And since these do take a little bit of time to run, I have already done these, and I'll show you now what this looks like. So, go to So this is the significant impact level run, looking at just the first high. And in this case, I had a group called Still, which was just stack 1. And you can see my concentrations all around here. And again, this is looking at first high. And okay, I do see that I have lots of receptors that are above the sill. This would be what you would consider a Tier 1 analysis. With Beast, if I want to get an idea of what my Tier 2 would look like, I can go over to Options and say I want to multiply these times the 1 hour ambient ratio method value of 0.8. And see the numbers have gone down, and the other thing I can do is I can come over here and say, oh, now just show me the ones that are over the sill of 7.5. And so some of them did go away. I do have quite a few that are still over the significant impact level, but it did get pared down some. So this now tells me, okay, I'm going to have to go back and remodel my cumulative impacts. How do I determine or filter out the receptors where I did not make an impact? If you then go over here on the left to the button that says radius of impact, put in that level of significance, which again is 7.5. Beast draws your radius of impact circle on there for you and tells you in the bottom left-hand corner that that is going to be 3.1 kilometer radius. If you right-click and click radius of impact receptors, you have two options. One of which is going to save all receptors within the radius of impact to a comma delimited file, or you can actually have Beast save just those receptors within the radius of impact to a comma delimited file. So if I click that guy, say save, so what Beast spits out for you are just the receptors, including their elevation and hill height, at which you exceeded the sill. And so for your cumulative modeling, all you would have to do is probably create a new Beast file and then just do a copy and paste into the blank receptors, and then you would only be modeling the ones that you had exceeded the sill on. So that's kind of a neat thing to have happen. You can now look at a sill analysis that did use PVMRM, and you'll see that we still have quite a few that are over the significant impact level 7.5. If I want to filter out those, I can do that again. And I did not compare between the one before and the one now in terms of are there more or fewer that exceed the sill, but you can certainly do that if you wanted to. If I did a radius of impact, and it still says my radius is 3.1 kilometers. So basically, in that case, it did not change the ROI. It may change the number of significant receptors that you have. And then last but not least, so now we have, in this particular instance, the impacts from all the sources, and this is in the form of the standard, the 8th highest of the max daily 1-hour values, and this was only for 1 year. In this case, you can certainly go in and concatenate, say, 5 years of data into a single file and run it as well. And one thing that I can also do is I can now say, well, now show me everything above the standard. Where do I have problems? And I have a few, to say the least. So I would probably have to go back now and figure out how to raise stack heights or add on controls, maybe refine my in-stack NO2 NOx ratios, all different things that can be approached. Let me turn that back off. I want to show, I believe this is going to show up. And this is another new thing that's in BEAST. If you'll notice here, this is group SIL. And as I said, I had a group called SIL that only consisted of stack 1. And if you'll notice, stack 1 shows up. The other sources, there's one here and there's one here, are grayed out. But when I look at group all, which is everything, that now they appear. So that's another new thing that was recently put into BEAST, was the ability to show on screen what sources are part of the group that you're displaying. So with all that being said, I will now open up to questions and comments, and turn the record off here.